So when object is at C, image position is also at C. Image position is also at C. Nature is real and inverted. And size of the image is size is at that object as that object when an object is placed between F and C. When object is placed between F and C, when object is placed between F and C, this is placed between F and C. An object is placed between F and C. Image position is beyond 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 C. And nature of the image is real and inverted. And size is enlarged. Compared to this, it is enlarged. Size is enlarged. When an object is placed at F, then image position is at infinity. Nature of the image is real and inverted. Size highly enlarged. When an object is between P and F, right? And then image position is beyond the mirror. Image position is behind the mirror. Clear. Image position is behind the mirror. Venaka mirror vanaki. Right. This is coding part, right? So it is behind the mirror. Front part is behind the mirror. Nature of the image is virtual and erect. Nature of the image is virtual and erect. Nature of the image is virtual and erect. Next, uses of concave mirror. Uses of concave mirror used in torches, searchlights, vehicle headlights to get a powerful parallel beam of light. Concave mirror are used by dentists to see large images of the teeth of patients. Teeth have to be placed between pole and focus, right? So the teeth should be very near to the pole. Then teeth have to be placed between pole and focus. A concave mirror is used as shaving mirror to see larger image. This is also same point. The face should be kept between pole and focus. Then it will be enlarged. Image will be enlarged. Large concave mirrors are used to concentrate sunlight to produce heat in solar furnaces. Large concave mirrors, large concave mirrors are used to concentrate sunlight to produce heat in solar furnaces. Ray diagrams of image formed by convex mirror. When object is placed at infinity, so image position is at F. Clear? This is appears to come, right? Image position is at F. Which is virtual and erect. So image position is virtual and erect. Size is point sized. Size is point sized. When object is when object is placed between pole and infinity. So next case, only two cases, right? When object is placed between pole and placed between pole and infinity. Clear? Pole and infinity. Pole and infinity. Then object is between pole and F on the other side. Object is between pole and F behind the mirror. Pole and F. So this is nature of the images. Nature of the image is virtual and erect. Nature of the image is virtual and erect, and size is very diminished. Here our size is very diminished. When object is placed between pole and infinity, pole and infinity, then image position is between pole and focus. Nature of the image is virtual and erect. Nature of the image is virtual and erect. Clear? Here you can see nature is virtual and erect, which is the image found behind the mirror, and size is diminished. So a full length image tall building tree can be seen in a small convex mirror. A full length image of tall building or tree can be seen in a small convex mirror. Use of convex mirror. Use of convex mirror. A full length image of tall building also can be seen through a small convex mirror. Use of convex mirror. Convex mirrors are used as rear view mirrors in vehicles because they always have an erect through diminished image and they have wider field of view as they are curved outwards. Convex mirrors are blind turns and on points of merging traffic to facilitate vision of both sides of traffic. Used in shops as a security mirrors. Side convention for reflecting of spherical mirrors. Sign convention for reflection by spherical mirrors. Sign convention of reflection by spherical mirrors. First one, the object is placed at the left of the mirror. All distances parallel to the principal are measured from the pole of the mirror. All distances measured in the direction of the incident ray along x-axis are taken as positive. All distances measured in the direction of incident ray along positive x-axis are positive, and those measured against the direction of incident ray along x-axis are taken as negative, like this. All distances measured in the direction of the incident ray along x-axis is positive are taken as a positive, and those measured against the direction of incident ray along x-axis are taken as positive. Distances measured perpendicular to and below the principal axis are taken as distances measured perpendicular to and below the principal axis distances measured perpendicular and perpendicular to and below the principal axis, perpendicular to and below the axis are taken as negative. Clear? Are taken as negative. Perpendicular. The distance perpendicular to above the principal axis, the distances perpendicular to above the principal axis is taken as positive. This is taken as positive. Clear? If you see the image, all distances are measured from the left side of the object, and the object is measured in the direction of incident ray, which is parallel to x-axis. In positive x-axis side is taken as a positive sign, and the rays which are measuring in the direction against the incident ray, which is in the negative x-axis side, is taken as negative sign. The rays which are perpendicular and upper side of the, which is perpendicular to the principal axis, perpendicular to the direction of the principal axis, and in the upper side of the principal axis is taken as a positive, and the ray which is perpendicular and downwards to the principal axis is taken as a sign of negative sign convention. So object distance is u is always negative, and full length concave mirror is negative. Focal length of concave mirror is negative. Concave mirror, focal length of concave mirror is negative. Focal length of convex mirror is positive. Focal length of convex mirror is positive. Next, mirror formula 1 by v plus 1 by u equal to 1 by f. V is the image distance, u is the object distance, f is the focal length. Magnification of spherical mirrors, it is the ratio of highest of the image to the it is the ratio of height of the image to the height of the object. I పైన ఉంటుంది, I నేను, right? So upper side, 0 is downward side, right? Height of the image by height of the object. So m equal to hi by h naught. M equal to hi by h naught. So also m equal to minus v by u. Clear? Minus v by u. Also m equal to minus v by u. M equal to hi by h naught. M equal to hi by h naught, and m equal to minus v by u. M equal to minus v by u. If m is negative, the object is real. If m is negative, the object is real. If m is negative, the object is real. Important conditions. See, if m is negative, the object is real. If m is positive, the object is virtual. If m is positive, the object is virtual. If hi equal to h naught, then m equal to 1. Image is equal to the object. Hi equal to h naught, then m equal to 1. Image is equal to the object. Hi is greater than h naught, then m is greater than 1. Image is enlarged. If hi is less than h naught, then m is less than 1. Image is diminished.